Hello, hello, somebody. Hello, hello, wherever place you are. I'm David Kyle, the owner of the channel, the YouTube channel, the Teacher Kyle Explains, especially containing chemistry and some physics or principles in it. Now, do me one favor. Make sure you like, you share, but more and more, make sure you subscribe to my YouTube channel. Teacher Kyle Explains. It contains a lot of things, especially that are meant for our learners in school. Now, without much ado, let's go directly into our class. Thank you. Now, thank you so much. Welcome back to our class. Remember, this is chemistry. Hashtag simple classification of substances. Now, what is classification? Classification simply means grouping. Grouping the substances. You group the ones that have got same characteristic, and also ensuring that if they are of the same characteristics, then you give them one class. For example, when you're talking of legumes, you know you've classified beans, you've classified maybe the others, so you've classified them. If you go to cereals, you are classifying. So you are talking of what you call classification. So it is the grouping of substances. Now, what about a mixture? A mixture, this consists of two or more substances. You mix them together. So the moment you mix them together, so you get something, you get a mixture. So that combination of two or more substances mixed together, and each component contributing a character in that mixture is what we call a mixture. So that is what you need to understand, especially when it comes to the issue of a mixture. So remember, we are saying that for you to do what we call the separation of a mixture, you need to understand the size of that mixture, the size of the components which are found in that mixture. Now, there are many methods of separating the mixtures, and we are saying that the first method here, we can talk of what you call the use of a magnet. Now, when you're talking of the use of a magnet, there is what you call the sulfur. The sulfur is one of the elements in the periodic table, so which I will tell you later when we get into form 2 work. So we have what you call the sulfur, which is yellow, which is yellow in color. So we also have the iron filings. Iron filings are always gray in color. Now, mixture means that you take sulfur and you put together with the iron filings so that you get one thing. So you will get a mixture that contains a gray-yellow color. Why am I saying a gray-yellow and not yellow-gray? Because during the nomenclature of a mixture also, you also need to take into consideration the alphabetical letters of the a mixture. So therefore you talk of the gray yellow, not yellow gray. Now, so during this time here, we are saying that if you use a magnet, there is one that is magnetic, there is the other one which is non-magnetic. So the one which is magnetic is the iron filings, the one which is non-magnetic is the sulfur. So if these two were placed in a table, in that you are able now to take a magnet and you allow it to go above the mixture of the iron filings and the gray. So at the end of the day, the magnet will attract the iron filings and the sulfur will be left behind. In that case, you have used a magnet in order to do the separation. Now, the question is, where are we applying this knowledge here? Does it apply in class alone? No, it is also applied in industries. For example, if you are talking of the flour mills, if you want to remove the iron particles in the flour mills, then you use what we call the use of a magnet. So it is very important, and also in a glass recycling and also in iron recycling. Now, I'm saying that this one here can be applied in 3 areas. So it can be applied in iron recycling, it can be applied in glass recycling, it can also be applied in the flour mills if you want to remove those iron particles. Those 3 are the applications of the use of a magnet. The other one that I want us to look at is what we call sublimation. Now, for sublimation, for you to understand what sublimation, we have what we call a sublimate, and we have the substances which sublime. Now, initially, we had said that sublimation is that process in which a substance, in a process in which a state of matter changes from the solid into gas directly without forming any form of a liquid. And the opposite is what we call deposition. So the opposite of sublimation is what we call deposition. Now, I'm going to consider sodium chloride. This one here is sodium chloride, and this is the iodine. Iodine is always shiny black crystals, and sodium chloride, which is the common salt which we all know, is white in color. So when these two are mixed together, allow me to open the diagram in which I want to show you something here, especially when it comes to sublimation. Now, look here. If this one here is the the iodine, and this one here is the sodium chloride, if you apply heat into the mixture of iodine and sodium chloride, this iodine here will rise. It will undergo sublimation in that it will now go as a vapor. It is a purple vapor. So it will go here. Because this evaporating dish contains water, and therefore this vapor here will undergo the cooling process, and it will form the shiny black crystals. In other words, the iodine vapor has moved directly from the solid into gas, now forming again the solid here down the evaporating dish. That is what you need to understand. So when the iodine has gone now here and has condensed here, the whatever remains is what we call now the sodium chloride. That is what remains here in this beaker. So, and now this process in which now we separate iodine from sodium chloride is what we refer to as a sublimation. Now, sublimation, we have substances which can sublime. We have what we call iron 3 chloride. We have what we call aluminum chloride. We also have carbon 4 oxide. In other words, is we in another name, we also call it what we call the dry ice. We have what we call the benzoic acid. So if you are told in an exam for you to mention the substances which undergo sublimation, we have the first one, which is iron 3 chloride, we have aluminum chloride, we have carbon 4 oxide. In primary, you say it is carbon dioxide, but in high school, we are saying that it is carbon 4 oxide. We have also what we call the benzoic acid. Now, this sublimation here is also applied somewhere. So it is applied in, especially with what we call the ice cream vendors. The ice cream vendors usually use carbon 4 oxide. They prefer it over what we call the normal ice, or other textbook will tell you ordinary ice. So carbon 4 oxide is mostly preferably used. Why? Because of two reasons. Number one, when it sublimes, it leaves no wetness. Very good. And again, we are also saying that it is also a better coolant. So there are two reasons in why carbon 4 oxide or the dry ice is mostly used or preferred to the normal or ordinary ice. Number one, there is no wetness, and number two, it is also a better coolant. Very nice, very nice. Now, can we look at what we call the decantation and filtration? Oh yeah, very good. Now, decantation and filtration, these ones here are mostly used to separate the solid liquid mixtures, especially the ones which are insoluble. For example, if you are talking of the soil and water, these two here, they can never mix. So they are called insoluble solid liquid mixtures, because we also have others which are soluble. Now, in our case here, when you're talking of the soil here now is what we call the soil here. The soil and the soil is a solid. Very good. Water here is the liquid, and therefore we are saying that these two here are solid liquid mixtures. Decantation is a good process. Oh yeah. In decantation you have two containers. There is one container which is always down there. There is another one which is used to deliver. which is used to deliver. So here you can have your sand, you can have your liquid flowing, and this one here will be our water, this one here will be our sand. So sand, water, very good. Now what about filtration? In filtration, we use what we call a filter paper. We use a filter paper and also a funnel. For example, here there is a funnel. In the funnel, the moment you do your filtration, there is what we call a residue. Residue are solid particles which remain on a filter paper. Now, the filtrate is that liquid which is always collected during the process of filtration. Very good. Once again, a residue here is a solid particle which remains on a filter paper or a funnel in the process of filtration. A filtrate is a liquid. This one is a liquid, but a residue, these are solid particles. This one here is a liquid. So that is what you need to understand. Now the question is, why do we prefer filtration over decantation? Why? Because we are saying that during filtration, you are obtaining a clear liquid compared to decantation. Because during decantation process, what happens here is that the solid particles also go together. For example, in our case here, so you can see the sand particles will go down here. So whatever will be obtained here, it won't be that clear, but it will contain some traces of the solid particles. But for filtration, the filter paper always acts as a sieving process so that it helps you so that you may obtain a clear liquid. That is what you need to understand in that case. Now, in the next class, I want us to look at what we call crystallization and also the other methods of separation. Thank you so much, and make sure you subscribe to my YouTube channel. That is Teacher Kyle Explains. Thank you so much. If you enjoyed today's class, and I do believe that you got a lot, you enjoyed, have you subscribed to my YouTube channel? Please, if not, do it once again. If you cannot do that, you won't see me. Thank you.